Good day, class. Today we're going to look at one last method of solution for a linear 2x2 system. This method uses determinants and it's called Cramer's rule. We're going to focus on Cramer's rule for the system of two linear equations in two unknowns, x and y, for the lesson today. So this document is posted for you in Blackboard, and for today's lesson, we are going to use the top of the page. So here is one equation in the unknowns x and y, and here is a second one. In this example, the constants are given by the letters A, B, and C. So what we do to begin with is we form a determinant. It's a 2x2 determinant. We're going to call it D, and it's formed by taking the coefficients of x and putting those in the first column, and the coefficients of y are put in the second column. This, of course, is after making sure your equations are in this exact form. Now, to evaluate a 2x2 determinant is pretty straightforward. What you do first is multiply these two numbers together. So A1 multiplied by B2. And from that, you subtract the product formed in the other direction. So A2 multiplied by B1. So that's how you evaluate every 2x2 determinant. So after you figure out that value for capital D, it goes in the denominator for your x and y value solutions. And what you have to do in the numerator of each is form a new determinant. To form the determinant here, the first column is replaced with the numbers from the right side. And to form the determinant here, it is the second column that gets replaced with the numbers from the right side. Okay? So what I'm going to do is go through that now with you in some examples. So this is the same system we looked at with both the methods of elimination and substitution. So we begin by forming capital D. And how is that formed? We take the 7 and the 2 and we put them in the first column, and the 6 and the 5 are put in the second column. So it's simply the coefficients of x and the coefficients of y, because these are already in perfect form. And now we get a numeric value for this. First, we multiply 7 by 5, and that is 35. And from that, we subtract 2 multiplied by 6. So value of D is 35 minus 12, or 23. And so that number is going to be our denominator for our x value answer. And it's also going to be the denominator for our y value answer. And what we need to do is form the appropriate numerators. Okay, so x is the first variable. So it is the first column that is replaced. and the second column stays as it was. So the second column stays the same. The first column is replaced with the numbers from the right side, like that. Okay, so the first column gets switched. And now we evaluate this top determinant in the same way. So multiply this way first. That's 100. From that, we subtract the product in this direction, which is 54. And so what does that mean? That means our value for x is 46 divided by 23. And that number, of course, is 2. All right, now we do the setup for y. Y is the second variable, so it is the second column that is changed. The first column, therefore, stays as it was. So the second column changes from 65 to 29, those numbers from the right-hand side. And then we evaluate that determinant in the numerator. 9 times 7 is 63. From 63, we subtract 2 times 20, or 40. The numerator now is 23. After dividing by 23, we get y is 1. So x is 2, y is 1, and therefore the two straight lines intersect at this ordered pair. And that's all there is to using Cramer's rule. You can see there's no algebra in it whatsoever. Okay, let's try the second one. Now it's also in the perfect order. We have x's, y's, equal signs, and constants. So it's set up properly. So let's begin by forming capital D. So in the first column will be 4 and 2. In the second column will be -5 and -3. So make sure you take the signs as well. So this is coefficients of x, coefficients of y. So let's work out this number. 4 times -3 is -12. From that, we subtract 2 times -5, which is -10. So there's always subtraction in between the two products. Well, now that's just -12 plus 10, or -2. So -2 is going to be that denominator when we solve for x and when we solve for y. Okay, so the -2 is underneath, and now we have to form our new numerators. So when forming x, it's the first column that gets changed to -34 and -22. The second column remains as it was. Okay, so the first column was changed. When you form y, it's the second column that gets changed to -34 and -22. The first column stays as it was. So as it was in capital D for 2. All right, and now we do our evaluation of each top determinant. Always have to go this way first, okay? There's no choice there about the direction. So we multiply -34 by -3. This is 102. And from that, we subtract, always subtraction here, The product in the other direction is negative 22 multiplied by negative 5. This is positive 110. And so x will have negative 8 divided by negative 2, and so it is 4. Let's work out y. We go this way first. Negative 88. Subtraction. This way now, this number is negative 68. So the numerator becomes negative 88 plus 68, which is negative 20. And after dividing by negative 2, we get y is 10. So now we have these two straight lines intersecting at the point 4, 10. And if you check back in your notes from our last two videos, you will find that we have obtained these same answers when we used elimination, and we obtained the same answers when we used substitution. Okay, remember that you can always check your answers. You would be substituting x equals 4 and y equals 10 into both equations. For example, like this, you would do 4 times 4 minus 5 times 10. So that would be 16 minus 50, and that certainly is negative 34. You can then substitute x is 4 and y is 10 in the second equation. So 2 times 4 minus 3 times 10. That would be 8 minus 30, and 8 minus 30 is negative 22. So this point works in both equations, and therefore it is certainly the intersection point. Okay, let's do the third example here. You might remember this is the one with the P's and the Q's. We've solved it already with elimination and substitution. So now let's solve it with Cramer's rule. Now, we have to first make our system look like this. Now it was x's, then y's, but in this case it will be p's, then q's. All right, so the p terms first, then the q terms, equal signs and constants. So how will that look? Well, in this first equation, this number right here has to move to the other side. So it'll be 5p plus 4q is positive 14. So from subtraction of 14 to addition of 14. And what about in the second equation? The only term moving will be this one. It moves to the left side, so it will be subtracted. 17p minus 3q is 31. Now that system is correct. You see, these are now the A values, the B values, and the C values. Okay, let's start by working out capital D. 5, 17, 4, and negative 3. Make sure you take the negative sign with the number. Okay, let's work out this value. We must multiply this way first. That's negative 15. Subtraction is going to be the operation. What are we subtracting? 17 times 4, which is 68. So our result is negative 15, subtract 68, that's negative 83. Now we need to work out P and Q. So we form two new determinants for our numerators. How do you form P? Well, into the first column will go these numbers, 14 and 31. How about for Q? The 14 and the 31 will go in the second column. How do we write down the second column here? We take the original second column. And how do we fill in the first column here? We take the original first column. And now we have them both set up, and we will evaluate. All right. Multiply in this direction first. That number is negative 42. From it, we will subtract 31 multiplied by 4. And that number is 124. So the numerator is negative 42 minus 124. That's negative 166. We divide that by negative 83 to find that P is 2. Now we go on and do Q. Multiply this way first. 155 minus, now we multiply this way, 17 times 14, which I think is 238. And so our numerator now is 155 minus 238, or negative 83. And we divide that by negative 83 to find that Q is 1. Okay, and we used alphabetical order to write P before Q here. And also in our answer, we write P and then Q. Just like this. Okay, and that's how you use Cramer's rule to solve a 2x2 linear system. So now, in total, you have learned 4 ways to solve a 2x2 linear system. They are the graphical method, elimination, substitution, and Cramer's rule. Okay, so these are the 4 methods of solution we have used to solve a 2x2 linear system. There will be one more topic included in this unit, and it is solving a 3x3 linear system with Cramer's rule. The concept is exactly the same, but I do need to show you how to evaluate a 3x3 determinant. Okay, so this we will look at in detail in our very next video. Okay, thanks a lot, and don't forget to try some practice problems. Actually, you'll be trying the same problems from 5.3 over again, this time using this latest method. Okay, have a nice day.